Bro. What the fuck is YouTube doing? YouTube ain't working correctly today. Let's attempt. Okay, that's what we're doing. We're attempting today. Attempting. Alright, another day. Another research. So this morning, I had a little bit of energy. I was still awake at that time. So, I actually did a little research, a little bit of research. So we're gonna be able to note that down, hopefully. Maybe do something positive. Now there was that thing that I think we would need to update a little bit. Like that. Alright, that's good. And that's good too. And that's good too. Okay, we're all good. So. That part when I talk about the fake thing, I'll just read it. I feel like I'm not describing a lot of cool thing about this, so it's kind of frustrating. The skeptics among you might say, what is the point of all of this if the host uses a fake PCIe device? The standard got you covered. Upon initiation of a connection, upon initiating a connection, upon connection with a TDI, the TDI will transfer an assigned version of their internal measurement, firmware version, and other hardware information. The signature can be verified against the vendor supplied certificate. Okay, no, I said some detail. And the measurement can be tested to confirm that the hardware wasn't altered. This ensures full confidentiality while relying on only the maker. While relying only. Duh. Fucking hell. While relying on only the maker of your hardware. While relying only on the maker. While relying only on the maker of your hardware. Alright. That's cool. Help. I think that was a hello, not a help, but still works. Hi. I think we're done with this, unless there's some like mega giga detail that we want to get into, but help. Happy to see you. YouTube really effed me, okay? YouTube didn't want to work today. But we're going to make it. Alright, so I read a bit. Today. I should be able to note down the things that I read. Should. Alright, so we were here. So let's just go down and note down everything, right? So we have fixing a thundering herd problem for Big Numa server. So big thundering herd problem. That's when a bunch of cores are trying to go for the same thing and it makes things slower. Alright. Sounds cool. So we should probably have in Arch, we should probably have MISC. And put that here. fuck? A thundering problem for big Numa servers. I should probably explain it. Alright. What did they even mean when they say Timekeeper CPU? I did not focus on that. You know what? Fuck this. I focused on one thing today. Should probably like get that out of the way. Okay. Scope user access. That shit hits. Alright. So, where do we put this? Alright, well, let's put this in MISC. Okay. So. So, no rabbit hole today, understood. I know, probably a lot of rabbit holes. I don't have any concentration today. But I'll at least note this, because I'm like giga brain about this. So, I'm just thinking about how to explain. Hi, Enigma. Alright. Scope user. I am so delighted today. Good, happy about it. Alright, scope user mode access. Okay, let's read this and try to have a brain, okay? Access to the user mode memory can be required in opcode path. But if it has to be done with user-controlled pointers, the access is shielded with a speculation barrier so that the CPU cannot speculate around the address range checked. Those speculation barriers impact performance quite significantly. This can be avoided by masking the provided pointer so it is guaranteed to be in the valid user memory access range, and otherwise to point to a guaranteed unpopulated address space. This has to be done without branches, so it creates an address dependency for the access, which the CPU cannot speculate at. Okay. Yes, you'll help me focus as usual. Alright, so we just read this, okay, so... That's good, we're good on that. Alright, so we just read, okay? We just read this. So the idea is that before, we had to do a bunch of checks and have a hard, okay? Speculation barrier, okay? So the address was trying to come true, it had the spec that shielded it, slows it the fuck down, and then goes on its way. So, how do they fix this? They talk about masking, they talk about a bunch of shit. Well, I read a fuck lot, okay? Because this is way more based than it looked, okay? So, in this thing, still kernel, still doing notes for the kernel. So, and right now we're doing scoped user mode access. Okay, so the idea, okay, so sometime in the kernel, I'll try to like giga focus today for just this. Yes. Okay, sometime in the kernel, you need to pass a user space pointer, and this user space pointer should of course only point to user space. So the issue that we have is that whenever this pointer passes through the system is able to check if yes or no, we are at the right place, right? The pointer, if it points to kernel data, it will just get a fuck you, that's not the right place. That's obvious. Now, the issue is that speculation doesn't have that check, right? Speculation can not give a shit about permission. So, how do we fix that? Now, the solution that they came up with normally was to just put a speculation barrier. In other words, slow everything the fuck down to make sure that there's no speculation. This is garbage. They went with a solution which is way, way, way better. And I'll explain to you, okay? You big brain, you'll get it, you'll get it. So let's take... You know what? I'll draw it. I'll draw it. Okay, so let's take the kernel memory. Alright? So this is the kernel memory. The more up, the more the address is high, right? So here is at address 0, and here would be the full 64-bit fucking range, okay? Or 48, or 32, whatever the fuck you use, okay? So, now, the Linux kernel, the way that it works, is it's split into different pieces. So 64-bit of memory is a fuck ton, right? So we don't need it all. Nowhere near. So what the kernel does is it will shoop, split it there, split it there. Now my division are not good. Like in reality, it would probably like look like this, but anyway, okay, let's do this like this, okay? So here at the top would be the kernel. Should probably erase a couple of things. Can I erase? Fuck, dude. Let's restart. I'll make it, okay? We are gonna make it. Oh shit, he's really fucking making it. Bro, this explanation is going to be fire. Alright. So same thing, the higher section is for the kernel. The kernel... Fuck. The kernel is somewhere in here. The user space is somewhere in here. And that's in virtual memory, of course, right? So user space at the bottom, kernel space at the top. Now, if you're big brain, just from this image, your brain is going to be like, oh fuck, we can truly just check if we're at the right place by looking at the last bit of the address, right? Because the user space will never be over the middle, which means that the last bit, the biggest bit, should always be set for kernel and never be set for the user. So now, with that knowledge, you might be tempted. Let's take an address. Let's say that we have 8-bit, okay, instead of the full 64. Let's say that we have 8-bit. So we have an address, okay? We have 2 addresses. Let's start with just one, okay? So 8-bit, so... okay. So we have this address. Now, you might be tempted to put some ifs, right? To say, okay, if this is set to 1, then do something, right? But ifs are bad. They're slow. They won't help in any way. So how do we fix this? Okay, how do we find a good solution? You might also be tempted to transform the last bit into a 0. Right? Just assume that it's a 0. But in that case, you won't be able to detect that something is fucked. Right? Because if the last bit is a 0, and it was a fucked address, then it will maybe, or maybe not, do an error afterward, but you didn't see that it actually tried to, like, go outside of the bounds. So that's bad too. How about I show you a magical way that we can, in x86, Not full x86, okay? The bare bones, okay? The first version. We can, instruction per instruction, not only know that the thing is fucked, but also find a way to, like, have an error for it, right? I'll show you, okay? We'll go on a magical way. A magical journey. Alright. So let's take this. This address is obviously a bad address because it has a 1 here, right? We know that. So the goal should be that we end up with something that will make an error from this. But that has no if in it, and that is, like, something that can run as fast as possible. So let's do this. The first thing that we want to do is we want to do a command called... Fuck, I'm trying to remember my x86. Right. Okay, I'll need to delete this part. Alright. Not at all what I wanted, but I guess we'll make something cute with it. You know what? Leave it green. Leave it fucking green. We're making it cute. Alright. Let's go. Alright. So let's take our 8-bit address that we had, right? Maybe it's not the same. Who gives a fuck? Okay. First thing that we want to do is we want to do what we call the right word algebraic shift. That's the x86, okay? I remember it. Now, not only do we want to do a right algebraic shift, but we want to do it for the number of bytes that we have in our address minus 1. So what a right algebraic shift does is it does a shift to the right, but it's algebraic. If you don't remember, algebraic assumes that this first value is a positive or a negative bit. So instead of just shifting everything to the right, if it's a 1, it will print the 1. If it's a 0, it will print the 0. So let's go into it, right? So we do one, let's say that we just do like one round of right algebraic shift, right? Let's do one round of it. So what it would become this. Like that. Let's do another round. Now let's go directly to the end, okay? Let's go directly to, we've done it 7 times. It looks like this. Now you might say, that's fucking retarded, Maple. You'd be wrong. Next step. We are going to do R H S. I'm 99% sure that I have my x86 correct, okay? RHS. A right word. Who the fuck knows what H means? Shift. Okay? Logical shift. So what we're doing, essentially, is we're adding a 0 on that side, right? We're doing this. Alright. So now you might say, Maple, this is giga fucking retarded. We have 0, we have a bunch of 1s. What the fuck are we going to do with this? Let me show you. Alright. So we have 0. And we have our 1. Now the next thing that we're going to do is we're going to do a... Oh, I'll write it here. We're going to do a NAT. Right? We're going to do a bitwise NAT. So we're going to invert all of these. And then we're going to do a AND with the original address. So let's do the AND with the original address. I don't fucking remember it, but there's only one possible thing that can come out of it. So who gives a shit, okay? So if we do an AND with the original address, we come out with what have we just achieved? So what we've just achieved is a way to mathematically remove all of the specificity of the request and only point to the address at the center of our little memory diagram. So let's think about our memory diagram again. Right? We have this little memory thing. Boom. Boom. What we're doing is we're pointing right here. Now this will fail. Right? Whenever we go through the command, it will fail. But it will also not contain anything interesting because the kernel is up here. Sweet fuck all is here. The user space is here. And we're pointing to literal nothingness. Now, just for the proof of concept, we're going to go through the same process, but for a valid address. Right? So we have 0, 1, 1, 1, 0. Well, that wouldn't be valid at all. Okay. So that would be valid, right? Let's do this. We do the shift. We do the RAS. So we do it 7 times. We end up with we then do the RHS. We end up with we then do the NOT. We end up with and we then do the AND with our original thing. And we end up with the original address without any change. So with clever math, we can now zoom right through and ensure that our address is not pointing to the kernel, thus not requiring any speculation barriers. Mic drop. Giga might drop, okay? It's funny when Nigma is saying shit, and I'm literally, like, not only saying the fucking x86, I'm saying the x86 here, okay? So Nigma, you cannot argue, okay? RAS, x86, let's fucking go, okay? I'm ready, bitch. I'm in caps, okay? Get me the R. Where the fuck is the fucking instruction, bitch? It's caps. How did I fuck it up? Where is R? Nah. I'm not fucking wrong. I am. Ripperoni. Wait, where the fuck did I get my x86 while working so that I don't have this? Bro, that's not possible. Oh, it was the Stanford thing. Was it? Oh shit, it's not. It's x86-64. Did I say RAS? Fuck. It's SAR. SR. Okay. Reverse the numbers. Okay. But I'm 100% right, okay? Bro, I was so deep. So deep. I took a picture with my fucking phone, okay? Of the fucking kernel docs. Okay. I'll go and yell at Nigma a little bit more. Okay. Okay. I'm good. I'm good. Bro, I don't want end break. Bro, did it just do absolutely fuck all? Okay. We're back. Okay. Okay. You know what? Let's literally go get my source. I just want to share the pain a little bit. Because I searched for so fucking long. Nobody explained anything. Bro. It's... The mailing list is unhinged. I need to share the pain, okay? Yes. Hi, Christoph. Okay. So that's me, okay? I'm... Okay. Fuck, I don't have it. Anyway, the first note shares nothing about how the things work, okay? The merge... Nothing, okay? So I start Googling around, trying to get an understanding of what they mean by masked user access. And the way that I got that term was from reading uxs.h, okay? So it was literally through my pure, like, on the verge of suicide trying to understand this. And I end up on this shit. And I'm like, barrier, no spec. Sounds all fun, right? Oh, and power PC. Let's take a look. So I start like fucking shit up, right? I'm like, let's click on a bunch of things. Let's click. I end up here and I'm like, oh, I'm gonna have an understanding for this shit. And this is pretty much the explanation, but without the retard language that makes it understandable, right? So I see these. Now the problem is that these fucking ingredients are all but understandable on their own. Like, I'm sorry, but like, this one is the most understandable of all, right? So this one is shift right algebraically, double word immediate. So I'm like, algebraically, I didn't know that I needed to check for what the fuck that meant. So I was confused for like an hour trying to unfuck this. Then and C. And C. What the fuck does that mean? And with complement. Thank you? What the fuck does that mean? So I Google around and I start understanding that bitwise complement is a not, okay? So it's just a not. Nothing more than that. So it's and plus not. So this one you apply not on it. This is where you save it, the R9. So you end up doing exactly that. And then there's this shit. This shit, bro. Rotate left, double word immediate, then mask insert. Fuck it. I don't know. I'm dead at that point, okay? I'm completely cooked. So I continue reading. I read the version for the 32-bit. I don't get it. I'm on the verge of suicide. I understood these two. I needed to understand that one. What the fuck does that even do? So then, is it that guy? Actually, there would be an even simpler, more obvious sequence. This is the literal equivalent of what I've done. Okay, literal same thing, but there's the and the not that are combined. So after reading that shit, I was like, okay, it's very easy. I wasted so much time, bro. Yup. The mailing list is for people that know what the fuck they're doing. Obviously, it's all obvious. Like, that part really fucked with me, right? And clamps it to 0x8000. I was like, how the fuck does it clamp it to anything? Where's the clamp? I was trying to find the clamp. I was so lost. Bro. And... yes, it's so easy when you think about it. Like, at one point I was like, okay, if you have an and, it means that it's a mask that's being applied, right? And if there's a mask, like, everything becomes easy at that point, right? But fucking hell. Alright. And also, I try to, like, parse through this shit and try to understand. Good luck. My understanding is not good there. Alright. Those keywords are not x86, they're for PowerPC. Yes, and that didn't help. Because actually, this is the implementation for PowerPC. Right? This is what's going to come in a future patch. Not now. I had to go look at that shit to have any idea. Well, I say not now. Maybe I'm wrong. Give me a moment. Where the fuck is the thing? Okay, thank you. Go there. Okay. So do we have a PowerPC patch? Oh, okay. So it's included? Question mark, question mark? Anything else from PowerPC? No, so it must be in here. Define, I'm sure. Yeah, those are all, like, very deep in defined magic. Alright. So it's probably already, like, working. Anyway. That would have confused me. Well, I knew from the start I only checked for PowerPC things. I already knew. Well, there's one thing that confused me, is that PowerPC, they have, of course, different instruction for 32 and 64-bit. But the issue is that the 32-bit is like an instruction that you can find. The 64 is like giga hidden. So here, when they say RLD, IMI, D is for double word. So you actually shouldn't search RLD. You should search RLW IMI if you want to get a remote idea about how this works. Because there's a good website, yeah. Phoenix Fox Studio. Like, I looked at this so much. And it's so good. God damn. Like, it uses, like, the math thing. It's so good. Like, I looked at this so much. And there's examples on the... Oh, man. This is erection-inducing, right? That's what you should have done. I don't know what you mean by yes, that's usually how it's done. But anyway. Yes, okay, Nigma, I know that you can always map and like make parallels to how the fuck like your command will do something algebraically. What I'm saying is that it's cool that these websites exist so that we can actually learn and not be like, oh, guess I'll just like have no fucking idea what the fuck they're talking about again. Right? That's the goal of KernelInfo at the end of the day, is to be able to have this, but for Linux. Like some real fucking knowledge. Alright, scope user mode access. Well, yes, it is secretive. It is secretive if it's not if there's not clear and easy documentation for you to get into it. I'm not saying that there's a conspiracy. I'm saying that it's like, fuck, we're talking about an architecture here. We should have a website for all of them that makes everything so simple to understand that even a Down syndrome kid should be able to understand it. And you know what? If by the end of this, like, KernelInfo thing, it doesn't exist, we'll fucking make it. Assembler info. You know what? We're going to have to create an organization, okay? So we got FSF, we've got fucking GNU, we've got the Linux Foundation, but we need the docs nerd. the Maple Docs, okay? That's who we are. We're the Maple Docs. We are making documentation. That's all we fucking do. Docs. Do you know how to build anything? I don't know. Docs. What did you build? Docs. Alright, scoped user mode access. There's probably a better way to word this. Let's go steal what Veronica said. Scope user access. Scope user... the mode. Scope user access. OMB. OMB. You know what just fucking got in my mind? Technically, if we did like a KernelInfo version for a compiler, that information would be... we would be there, right? Like, what architecture are not covered by LLVM? Anyway. Oh boy, we're putting some fucking projects on the... Non, maudit sa planche. On va dire ça de même. Oh man. Anyway, scope user access. Magic. We're gonna need to make some docs for this. Because technically, the, like, there's a thing about architecture, is that it's more permanent than Linux, right? Well, with RISC-V, well, with RISC-V, okay, it's almost as permanent. It's, no, sorry, it's, fuck. Architectures are more permanent, they don't change as often. Okay, Nigma, go read. I'm not frustrated, I'm not saying this like as an insult or anything. Go read RISC-V, like, architecture, and they're not okay. They're not okay. Those people are unhinged. It feels like they have a new extension every week. Okay, magic instructions. Removed speculative barriers. Ah, fuck. How will I phrase this? Speculation? Remove speculation barriers from the scoped user access code. Okay. Magic instructions remove speculation barriers from scoped user access code. They should not change often because they are the base structure from which everything is built. You change that and everything is to be adjusted, tested again. Yep. But I think that's kind of the idea of RISC-V. Is that you make it so modular that everybody can do their own shit. But you're ending up in the same issue that all, like, overly modular things have. Is that it's so confusing to know what the fuck is going on. Like, should I use Zigbop or the 15th other option to do the exact same thing? Who knows? Two. So you need to recompile for it to work. Bro! Well, not necessarily recompile, but then if you don't, you make your executables, like, not as efficient. Or at least heavier. I don't know how RISC in general is good for computation, but oh, okay, I think we're not talking about the same thing, okay. Yep. Like, to me, Enigma, what MB just said is why RISC is so inferior. But you're probably viewing this from an idea of, like, I can make the perfect CPU for this use case. And I'm seeing it from, if your CPU cannot be, like, needs to be redesigned to be sold, it's shit. So, like, anyway. I understand. Okay. Okay, I need to redo the explanation. Okay. It is required. Fuck. Some operations require the kernel to use pointers that have been provided by the user space. Fuck it, I'll dash it today. These pointers are deemed unsafe and require to be tested. How do I say that it will fucking fail in paging without explaining paging? Okay, these pointers are deemed unsafe. Point to your video about memory. I don't know. Yeah, maybe. Oh, yeah. Fucking hell, MB. You got that shit. Okay, so it could be something like, these pointers are deemed unsafe and require to be tested by the CPU. Because that's true. It's the CPU doing that job by the CPU. If want to know more, I'm just bypassing that shit. I have a video on the subject. Bro, that is show it on the screen. And anyway, I think I'll be able to word this shit correctly. Yep. I don't know. Did I even explain this correctly? Wait a minute. I got a copyright, like, not claim, but like my main channel was saying Hey, somebody's using your content. No shit, bro. No way. Anyway. Ooh boy. Okay. Hello and welcome to this new episode of Linux Kernel Internals. Today, memory management, page table, folios, schematics, and more coming up. Get in, bitch. Okay. Okay, did I explain this correctly? I'm stressed. Make sense of where things are physically on your memory from a virtual address. Now, let's just go into the CPU and do things step by step to understand things a little bit deeper. So the first thing that the CPU will do once there's a request to read or write or pretty much do anything is to ask the translation look-aside buffer, the TLB, if it knows this memory address. So if we've already tried to read that memory address or write that memory address, we will be able to look into the TLB and fix this. So here, what you're seeing is what we call the page table. Now it looks complicated, but it's really not. So at the top, I'll just keep a virtual address for reference, and we're going to go through step by step how the Linux kernel, how the page fault handler actually finds the physical address. Now, the first thing that it will do is it will check into the CR3 register. So inside of your core, you have a CR3 register, and inside of that register, as soon as you have a process on that core, it will put its own PGD address. The PGD stands for Page Global Directory. So inside of our CR3 register, we have a bunch of bits which are there to point us to the Page Global Directory. Now, that Page Global Directory is a full page frame of memory, so it's a full 4 kilobyte of memory that contains a bunch of entries. Now, the CR3 doesn't give us the actual entry that we need to go to. It only gives us the page global directory itself, the 4 kilobyte chunks. To be able to choose within that page global directory which entry we should use, we are going to look to fix this. So here, what you're seeing is what we call the page table. Now, it looks complicated, but it's really not. So at the top, I'll just keep a virtual address for reference, and we're going to go through step by step how the Linux kernel, how the page fault handler actually finds the physical address. Oh, fucked. Yep. Bro. Do I give a fuck? Do I give a fuck? Do I give a fuck? I don't know. No, the big issue that I have right now is that I don't explicitly say that it's the hardware doing it, and in a lot of time it sounds like I'm saying that it's Linux handling it, and it's not. Fuck. All right. I'll reword this, I guess. Yes, but I was explicitly talking about an x86 setup. So I'm a fucking liar. Well, look, I can link to it and then say... look, I'll phrase it in a specific way. Fuck it, I'll still point to it. Oh, I am shameless. Okay. I write in the comment that it was fucked, so I'm legit. You see, Enigma. What you saw, right, is the lowest of the standard that I can go. If I go any lower than that, I'll kill myself. So, yeah. Okay, these pointers are deemed unsafe and required to be tested by the CPU. If you want to know more, I have a video on the subject. Anyway, just assume. Anyway, I know. Even if the CPU knows if a given address is should be accessible by the user space. Speculation doesn't. Which means that we need to prevent the speculation from running a malicious pointer. This is normally done. True. Speculation barriers that will significantly slow down the execution. I don't know. In which world are you, Enigma? Are you becoming Ned? Are you becoming Ned? Yeah, I should probably do like a... Like sometime in the video, I sound like I'm like locked in, and I do like a fucking 3-second like explainer for a thing that's more casual, and then I go back. I should do that like right there. Remember, speculation is the ability of your CPU to read and load ahead of the currently running instruction. That's not a good explainer. Oh yeah, true. I should explain why ifs are bad. Although I don't even know if I could, like, say it correctly. Yeah, this needs to be rewritten. I agree. The highway and exit analogy works well. Holy shit, I had the same analogy in my head earlier today. Thank you. Holy shit, this is true. Okay. Wait a second. We will rephrase this. I'll try to keep this in mind. Okay. Remember, speculation is the ability of your CPU to fetch... Oh, fuck. Yeah, I'm just trying to think about how to say it. Because there's a vibe aspect to it. If I sound too robotic, I won't be able to read it whenever I make the video. It triggers me. Alright. Let's think about this. Remember, speculation is the ability for your CPU to read... Fuck. To fetch... That's a good one. To fetch instructions... before they are actually needed. Wouldn't that, like, help? Remember, speculation is the ability of your CPU to fetch instructions before they are actually needed. And then I could, like, go into detail if the for example, jump instruction with a malicious pointer might leak. Kernel memory. Doesn't that, like, sounds good? Remember, speculation is the ability of your CPU to fetch instructions before they are actually needed. For example, a jump instruction with a malicious pointer might leak kernel memory. Speculation is using a crystal ball to get there before. Yep, that's pretty much it. I feel like I'm not making the example great of, whoops, of like where the fuck it comes from. Yeah, I corrected it. If there's a little like a red thing under it, I use the auto correct. Oh, malicious address. Yeah, that's true. That's true. Okay, before I read anything else, I should explain that the speculator, the speculation gets the address from fucking thin air. Okay? So this is a thing that needs to be understood, because if not, and pointer should be, address should be used here. Pointer is a shit word to use. These address. Oh, maybe here. Fuck it. I'll use pointer here. Okay. Remember, speculation is the ability of your CPU to fetch instructions before they are actually needed. For example, a jump instruction with a malicious address might leak kernel memory. The speculation hardware hardware. Okay, the speculation hardware doesn't have. Okay, the speculation all the hardware will essentially guess an address, and this guess might be poison. Okay, is that like a wording that fucking works? Then I need to rewrite this, right? So I'll just... Hi, Cardian, we're trying to make a video. Alright, I'll reread this shit. Magic instructions remove speculation barrier from scope to user access code. Some operation require the kernel to use pointers that have been provided. I'm not sure if I want to use address for these. Fuck. To use pointers that have been provided. Address. Use addresses? Fuck. If it's plural, it will sound like shit. Pointers, it is. To use pointers that have been provided by the user space. These pointers are deemed unsafe, and required. Okay. Are deemed. Fuck, brain. Are deemed unsafe and required to be tested by the CPU. If you want to know more, I have a video on the subject. Anyway, even if the CPU knows if it's a given address, even if the CPU knows if a given address should be accessible by the user space, speculation doesn't, which means that we need to prevent the speculation from running a malicious pointer. Remember, speculation is the ability of your CPU to fetch instruction before they are actually needed. For example, a jump instruction with a malicious address might leak kernel memory. The speculation hardware will essentially guess an address, and this guess might be poison. That's pretty fucking good. Happy to see you, Cardian. Happy to see you. Hi, YouTube! This, normally. Barrier that prevents... Yep. Barriers that prevents using fetch instruction. Okay, this normally... I'll just fucking... Fuck. My brain. Sorry. This... Barriers that prevent... Wait, what the fuck is my brain doing this? Sorry. Give me a second. Okay. Had barrier prevent using the fetch info from speculation. Yes, I'm just trying to make it fit with this. Okay, you already made it fit. Fuck my ass. Not literally, but I'm getting raped mentally right now. Okay. The barrier prevents using the fetch into... Okay, the barrier prevents speculation from fetching any address at the cost of slowing down execution. Yep, let it cook. Alright. Let's just scroll back up a little bit and read. Anyway, even if the CPU knows if a given address should be accessible by the user space, speculation doesn't, which means that we need to prevent the speculation from running a malicious pointer. Remember, speculation is the ability of your CPU to fetch instructions before they are actually needed. For example, a jump instruction with a malicious address might leak kernel info. The speculation hardware will essentially guess an address, and this guess might be poison. The barrier prevents speculation from fetching any addresses at the cost of slowing down execution. Do I use barrier anywhere? Over here? Nah. The kernel usually uses barriers to... Okay. Think we got it. Whoa! Okay. Bro, how do we write this? Okay. Remember, speculation is the ability of your CPU to fetch instruction before they are actually needed. For example, a jump instruction with a malicious address might leak kernel memory. The speculation hardware will essentially guess an address, and this guess might be poison. The kernel usually uses barriers to prevent speculation from fetching any address, at the cost of slowing down execution. First line. Fuck, what does this mean? Forget it. Okay, I'm good. MB be like, you're good, retard. Keep on pushing. Alright. At the cost of slowing down execution. Now, this may seem like I need to let you write your ideas before suggesting things. I understand. I'm just half brain dead right now, so it's a little bit, it must be frustrating. Okay. I think I'm like overthinking it. Or under. Who the fuck knows? Who the fuck knows, brain? Speculation is when the CPU buys branch stocks, predict a bullish market for user growth. Ah. I should... You know what? If ever I make a clip channel, we will have, like... like, live stream explanation. I'll use fucking oil stock to explain how memory works. Okay, guys. So you need to invest all your money in fucking Synovus, okay? Oh, you lucky? Well, not lucky, but I wish I had 16 hours to sleep. Cardian is memeing Nigma. It's a joke he's doing. He doesn't need correction. Yeah, that's what I was saying by it is, it's not. But I wish I had time to sleep. But okay. Now this may seem like oh, I should do like a until now. The kernel usually uses barriers to prevent speculation from fetching any address at the cost of slowing down execution. I felt that, Nigma. Alright. The kernel usually uses barriers to prevent speculation from fetching any address at the cost of slowing down execution. This release presents a new solution. This release presents a new solution, but to understand it, that we will need to understand how the kernel organizes organisms. Organize. Oh, with a Z. All right. Organizes memory. D. Virtual address space Z equals Canada. Whoops. Organized. Yes. S is in USA. Well, shit. I'm Americanized. I need to explain virtual address space. Fuck. Best of both world. Organize. Rabbit hole today again. Yes, it seems like we're fucking digging again. Digging. Easier ones. Yes. Not having to go through fucking PCIe 7 Redacted documents. Easy. All right. All right. Fuck. How would I phrase this? Okay, this release presents a new solution, but to understand it, we will need to understand how the kernel organizes memory. Each program when starting, each program creates its own. Creates is not a good word. Is granted its own virtual address space. This address space is divided. Okay. Is divided in multiple section. Drawing on screen the drawing that I did. So you do like right? We know those rabbits. We kill the fucking rabbits. What it? You don't like my voice. What the fuck? Alright. This address space is divided in multiple sections. Oh, it's because I'm doing retarded accents? This address space is divided between multiple sections. Smaller addresses. Smaller address. Are used for the user space. And higher addresses, I guess, addresses are reserved for the kernel. I should put some spaces in there. I want you to understand. I want you to Okay, this release presents a new solution, but to understand it, we will need to understand how the kernel organizes memory. When starting each program, each program is granted its own virtual address space. This address space is divided in multiple sections. Smaller addresses are used for the user space, and higher addresses are reserved for the kernel. Yes. Important note. Important note. The user space will always be in the lower half as the kernel space always be in the upper half. I'm like saying the same thing, but I don't know if I need to like make it fucking important. This means that by looking at the most important bit from an address, we would be able to know if an address is valid or not. Alright. The address space is divided in multiple sections. Smaller addresses are used for the user space, and higher addresses are reserved for the kernel. Important note: the user space will always be in the lower half, as the kernel space will always be in the upper half. This means that by looking at the most important bit from an address, we would be able to know if an address is valid or not. Distinction between virtual and real one, I think that we not give that detail. Even then, it's not true. Like, for all that we're going to talk about, physical doesn't come into it, and we should never talk about physical address, ever. It is cancer. It makes everybody's brain go mush. And it is never used. Well, yes and no. Right now we're strictly virtual, and there's no need to know anything about physical. Later in the release, there is... I hate myself. Later in the release, there is Intel LASS, or ASS, as I like to call it. So it's linear address space separation, and it literally builds on the same thing, but we if we want to explain it correctly and not bypass it, we need to explain paging. And I wanted to completely fucking skip it. Because I was like, no fucking way I go on and explain all of that shit in detail like a retard when I can just say, look, we know earlier we talked about something that was an ass. So, look. Anyway. Fuck this. Bro, Intel is trying to end me. Intel, what are you doing? Yesterday, TDX. Today, alas. I don't even know. I'm like trying to kill a moose with a hand grenade, okay? I'm not even hunting the right shit. Nigma, I'm trying to find some Swedes. Alright. Okay, the problem here is I need to explain why ifs are bad, but I don't even know if I fully understand why ifs are bad. Fuck. Like, ifs are bad. Besides stopping execution, why the fuck are they bad again? You're making memes. Good. Yes, why are ifs bad? Nigma, explain it. Now! Because they need more instruction. I just thought there was another explanation other than, like, ifs are bad because longer, right? Wasn't there, like, oh, fuck, I'll read the poll again. If we take a path that wasn't predicted, all speculation thrown away. True! Oh, it explained it. Okay. Okay, fuck. Okay. 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 Okay, so I went down like multiple rabbit hole. Like I'll chalk it up to ifs are unoptimized and that's it. I'll phrase it better, but that will be. Well, it's not jump to an unknown address, right? Because the address would be static in most cases. Anyway, fuck, I'll phrase it in a way. Okay, let's just read it. Let's have a feel for it. In that case, no, that's the issue. Oh, okay, you're talking about Nigma. Okay, good. Alright. Alright. I'll read it back, and I'll try not to stutter. True. Okay. No to you. Fuck. Alright. This is what existed before. Maybe just flashing it on screen will be an argument. No, but an if, you could still have some amount of specu... Oh, okay, no. We're being retarded here. Right? Because okay, that's my brain. Sorry, I think that's just my brain. Because you're saying like, oh, but we don't know where the jump is going to go, right? And in my brain, when I hear we don't know where the jump is going to go, I hear like we're going to use fucking RAX. Whoops, sorry. We're going to use RAX to send us through the stratosphere and beyond and use speculation up the ass. But no, that's not what you're talking about. What you're saying is there's a jump to address 1 and there's a jump to address 2, but because there's a conditional, we don't know which one we're taking, right? That's what you're saying. You're not talking about like a fucking RAX register or a R11. So yeah, I maybe you were thinking about the maybe you were thinking about the register, but I just gave you a better reason. It's okay, it works too. Because technically none of the address are unknown in these states. It's just we're still fucking with the predictor. What is that way of phrasing things? If we have an address, then we just fetch the bytes through DMA while the CPU beats its ALU. Give me the bytes! Bro. All right. I'm not debating anything. It's just funny. Oh, we're not talking about the same thing then. Because here, we are in the preparation code before the address, before doing something with the address, right? So here, we're not actually executing the address anywhere. We're like in the pipeline of... So we're starting from user space, and we're trying to get to kernel space. We are here, right? So we are not directly executing it. We just need to make sure that it's safe. So our jumps that happen here, they are already set to specific places. They are direct jumps. We're not using a dumb register to do it. The jump is going to happen here, right? The jump using the address given by the user happens on the kernel, like that side. Here, the jumps that we're talking about are jumps that are like already set in the code, direct branch, not indirect branch. But it is in a pipeline to know if the jump to a dynamic address. Yes. I agree, but here Okay, the whole technique. Okay, the reason why we need this is because speculation barriers are shit and they use ifs. No, sorry. Because speculation barriers are shit. That's first thing. Okay? So, we need this because speculation barriers are shit. So if we remove the speculation barriers, we need to confirm that we're not going to read the kernel. Now, if we want to confirm that we're not going to read the kernel, we're going to look at the most important byte. Now, the first question that will come in the mind of everybody watching the video is, if I have an address that looks like this, why don't you do if this is true, then do this, right? Why don't you just do that? Why do you go through the whole fucking instruction journey? It sounds retarded. So, I'm just trying to see how I would justify this, right? And the justification here is that it's faster. Why? Now the truth is that the ifs to check this thing are probably as heavy, if not heavier, than just doing the 3 instruction or 4 instruction that I showed earlier. Yes, I agree with that, MB. Like okay, maybe we are trying to remove the if from the barrier. No, that's the wrong way to put it. When removing the barrier, you require a new if. And I need to justify why that if shouldn't exist in place of what we're doing. So the justification would be that the ifs would be slower. And I could say that it's because hardware that's meant... People don't know why ifs are slow. So I would just say... If I don't address it, I feel like it sounds fucking retarded. Yeah, we would probably need to write some sample code. You did not, Enigma. If you did, it's not clear. Just to be clear for anybody watching, the reason why this needs to be explained is because if I don't, I go into like, oh, we're going to do right word fucking algebraic shift 7 times to the right. So if I go down this whole fucking explanation, the guy with the ifs look fucking insane. Look very reasonable. Okay, Enigma, when you're doing that, what you're essentially saying to the viewer is, I'm not giving you any new knowledge. You're just take me at my word. It's slower. I can do that. It sounds like shit. Right? I can make an analogy, but analogies, you usually should keep it for after being, after having explained it, or if it's something like so bare bones, that it's not explainable any other way. I'm trying my best, alright? I cannot think like a rock. That's fair. That's very fair, Enigma. Yes, it could be a nice conclusion. I think I'll just, like, say that branching is bad. I think that will be it. We're just going to go branching is bad. Oh, this is so dumb. Wait, I'll phrase it. I'll phrase it. Ah, yeah, you know what? Let's take a meme break. Oh! Brain rot content farm channel, YouTube good channel, unpopular channel that are better than the good channel. Based. Okay. Enigma, freaking awesome idea. My throughput by time/action. Alright, that's fair. Casual talk, sleep. Sudden misinformation. Real shit. Indeed. Address space buffer. Corporates need you to find a difference between the picture and this picture, Enigma. They're the same picture. I don't disagree. Branching. I know you said branching. Branching is bad. Explanation in a future video. If you ask in the comments. Based. That's so shameless. I love it. Leave a like. Oh. Just say that ifs are used by Microsoft. I need to do like a fucking Brody level conspiracy on this shit. Like, you know that Microsoft uses ifs, and ifs are contained inside of milk. Oh man. Microsoft. Oh, brother. Alright. Need. We're doing a Nintendo. Linux doesn't use branches. What the fuck is that? We use purely fucking linear programming. Okay, we can read the fucking future. Ifs. More like. Bitch. Alright. Enough memes. Alright. Alright, blah, blah, blah. Let's... No. That was more like... Okay. Let's apply this new... This knowledge to... fucking phrasing. Go-tos. Isn't there like some YouTube videos that are like all the go-tos in the Linux kernel, and there's like 100 of them? Like, why are we even talking about them? Yeah, I should probably go too, but we'll see each other tomorrow. And by the way, tomorrow I may be a little late. Maybe I'll start at 7:30. Who the fuck knows? So, yeah, I'll spam Discord as usual. Love you all. Love you, MB. Love you, MB. All right, let's think about this. I don't know what to say other than Nigma. I expected exactly that from you. Exactly that. Like, I had to read your comment 2 times to know that it's exactly you. All right. So, this means that by looking at the most important bit from an address, we would be able to know if an address is valid or not. Now, you might be tempted to use an if to. Now, you might be tempted to use an if, not and, an if to test the most important bit. But that would be a mistake. Ifs introduce branching, which is undesirable in undesirable in critical code. Let's do a bit of assembly. x86 64 assembly to understand the solution. If only answering the comments was useful, Nigma. If only. This is why I'm doing this shit. MD64, according to some sources. Base. No, I need to state that it's the 64 version because I was like yelling at Nigma at the start of the stream. Being like, I fucking got the commands! And Nigma was like, maybe not. As a total fucking guess. And I was wrong. So, yep. Nice one. Okay. Let's do a bit of x86-64 assembly to understand the solution. You were rage baiting, but like you ended up being right. It's the worst type. It's the worst type. Okay, so here I would like do the explanation. So let's take an address. Let's hurt the soul. Yep. Oh, sorry, I'm a retard. Alright, this... I'll explain it to you, Cardian, if you want to know. I'll explain to you what all of this shit means. Wait, I'm doing something retarded here. Whoa, 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 whoa. Okay, what the fuck am I writing here? Okay, so first we shift. Oh, fuck, we shift algebraically. Okay, sorry, I was wrong. Bro, I was so far. Okay. Would appreciate it. Alright. I'll explain it, like, right the fuck now. Alright. So, our goal here, make sure that the pointer is safe, right? So, we know, kernel memory, we've got the sections, right? So, inside of your program, you've got your address space. So you've got your address space for the user space, you've got the kernel space, and you've got, in the middle, absolute fucking nothingness. So whenever you check here, if it's above, if the last bit, so if you have a big address, whoops, sorry, I know you don't see. Okay, if you have a big address, if this bit is set to 1, it means that it's in the kernel space, so it should be rejected. If it's set to under 1, it means that it's somewhere probably in the user space, so it should go through. So that way we don't have to fuck around with speculation and find out. So now that we have that check, how do we implement that check? We cannot put a if it's too slow. So what we do is we first do a shift, a right word shift, algebraic, fucking hell, algebra, okay? So what that does is it takes the first bit, and whenever you shift it, so here, see the first bit, whenever you shift it by 1, it doesn't, like, just shift it. It takes that first bit and it duplicates it, okay? So it would become, like, if I do just a shift by 1, it would become this, right? And then if I shift it again, it would become this. So if I do it 7 times, it would all become 1s. But if my address was starting by a 0, it would all be 0s, right? So what I do from there is that I shift to the right logically, which means that if my address is a good address, it will all be 0s. If my address is a wrong address, it will be 0, 1, 1, 1, 1, 1, 1, 1, 1. So a little bit like that, right? So this is a wrong address. So whenever I shift algebraically to the right 7 times, I have a bunch of 1s. I do one last shift to the right, it adds a 0. Then what I can do here is on that, I do a not, right? So not this value. Let's put it in parentheses. So what it does is it will invert all of this shit, right? So it will become boom, 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 like that. So now it's inverted. So now what I can do is I can apply this mask onto the original value. So if I do an AND, so I do this mask with this value, it will become this value. So what that means is instead of having something that if it passes through speculation, it might like go somewhere we don't want, in our case, it will go whoop, whoop, whoop. It will go directly on the middle where it will still fail because it's not at the right place, but it won't be able to read any important kernel data. So that's the idea, right? That's how it works. So we're just using some simple ass assembly to do this. Now here it's for instruction, but there's ways to compress it. That's the idea. Hope you enjoyed the explanation. With animation, it will help. I did the full animation thing with them at the start of the stream, but I think I addressed it. All right. So we're pretty much just doing maths to be able to change a wrong address into an address that is inert but still wrong. And if we were, that's something that I should do, right? If we are doing the same thing but for a valid one. So valid, right? Let's do the same thing for a valid one. So here we have a valid address. So what it would become here would be a bunch of zeros. So we pass a bunch of zeros here. So remember, if we're doing the algebraic, right, shift, it takes the first value here and it expands it. So zeros all the way. Here, we're doing a right shift. That's a logical right shift. So we're just shifting right again. So we should still be full of zeros. Then we're doing not. So we're inverting all of our values. So that would mean that we have ones everywhere. So then, when it comes to compare our... Well, not compare, but do an AND on our original thing and our mask, we keep the full address that is not pointing to the kernel. Right, so no change in address because it's a valid one, change in address because it's a not valid one. It is really fucking clever. And like no ifs, no dumb checks. Pure balls. So like I'll need to yap for this, but I'll find a way to yap. I'll yap. Alright, I'll put some like signature, some sources. Okay. Okay, we should probably say like dispatch. This batch allowed to clear a lot of ifs. Allowed to optimize. Optimize. Allowed to dispatch, allowed to optimize. Do we have a bench? We don't have a bench, right? Oh, I should probably say which architecture got it. This the underlying assembly was added for, and I could say x86, ARM 64, PowerPC, your mom. Okay, x86, ARM 64, PowerPC, S390. Oh, RISC-V. Risky risk. Let's put it there. RISC-V. The underlying assembly was added. The equivalent. The equivalent assembly was added for x86, ARM, ARM64, RISC-V, PowerPC, S390, bringing this optimization to most architecture. Bringing. Bro, there's a mistake here. I know, bitch. Okay. Lord Syrup, I have once a man, once more arrived with more nerdy memes. I'm in. I like that name. I am Syrup. LLMs with code be like. This is so true. Bro. Bro, no. No. Alright, boys. How do we make more revenue even though we have enough? Spend 20% to gain 1%. Still, and say you didn't. Be a delightful company and gain trust. Okay, no. No, you get the judgment face. Because you're against capitalism. Isaac, hi. That most significant bit expansion thing usually is just annoying. Never thought it could be used to do some bit magic. True. The part that is unhinged about, like, the bit expansion thing is that it allows you to do, like, negative division. Which sounds fucking unhinged, but, like, it works. That's why it exists, to my knowledge. Then companies wonder why Steam is so praised. Steam is praised because it's their fucking job. They're a company too. Okay. Love you, Enigma. Love you. But like, when you see that shit, like, doesn't your brain go, how many places? Like, would a severely autistic dev be able to do some pretty base shit, right? Like, put Enigma, like, somewhere in a cage with, like, 5.h files, okay? Just 5s. Let him cage him up. And make sure that he doesn't come out until this shit runs fast. I'm sure you would. I'm sure you would. What are we talking now? I'm talking about... Okay, whenever you see these optimization, like, it's unhinged how, like, cool the optimization is. No, you don't understand it, okay? Necessity will bring innovation. I want an excuse to put you in the cage. Coolest thing, it is truly is fully arch independent. Well, it is arch independent, but it is arch independent because of how basic the command are. Right? And that's probably the most unhinged part of this. We're not using, like, okay, for PowerPC, they have a and a not that is combined, so it's one less command, right? And technically, this clearing out of the last bit could be done through, I know that some, like, architectures have the ability to just fucking punch bits. Or you could also do a and, but with a 0 here, right? So there's, like, a fuck ton of ways that you can do this. So, yeah. A rainbow starts to slowly have its opacity decreased. Aww. That's sad, Nigma. I know that I don't need anything and that you'll be delighted to help. I'm making memes too, okay? I don't want to put you in a cage. I'm just memeing. But to me, like, AVX Yes, it is bullshittery. But it is still very fucking cool, right? Like the idea of having this unhinged like thing that can just take like 512 bit and just just like fucking shit a thing is cool. By pre-inverting the end and using I don't think that would work, Nigma. Love you, Nigma. But yeah, like, Guardian. Like, how unhinged was it if they decided, like, if everybody in this godforsaken Earth decided that we were all going to use the same standard, right? The same fucking thing, and we're just going to go for it. Go for it. That would be cool. We could just have some crazy 512 shit at a time being processed. Bits wouldn't even matter on your CPU. We would just make some base code. But no. I can only dream. Why would everybody do assembly to this level if it's not to be universal? Alright. Would be a good thing for me to go. I should sleep today. Tomorrow is going to be a big fucking day for me. Just basedness and gigachadness guiding the electron. Based. The electron are guided by the hand of God. Think of the 0.001% efficiency. Think of the efficiency. Yes. Okay. I'm always thinking about more efficiency. What? We are gaining 0.001%? I want it. No, but really, like, we say, like, oh, we're doing, like, small optimization. Brother. Wait a fucking second. These fuckers have been cooking for real. Okay? Just before I go. Where is it? Oh, that's here. Okay. Provide up to 14% performance improvement for PostgreSQL. What the fuck is this? One patch. And we're not talking about like some unhinged, like 15 trillion threads. 8, 32. Like, what the fuck? Like, the fact that they still find this? Yep. Yeah, they did some rework on a memory management subsystem. I still have no fucking idea what the CID does. It's like concurrent CID for the memory management. But it's unhinged. Anyway. Like, it will be a nice Linux kernel to review. Man, I never have enough time, and I know that if I start too early, I don't want to do it anymore, so... Oh, what the fuck, Volt? Yeah, I'm supposed to go. Oh, man. Love you, brother. It's going great. Hope you're going well, too. We're technically preparing the kernel vid. So, kernel video will... A long arch! Yeah, they're doing a 32-bit arch. So they have a restricted version, a complete version. So the ABI has been sent to GCC for confirmation. But right now, it shouldn't compile for the kernel. Yep way. And it makes sense, right? Because you would want a 32-bit long arch if you're China and you want to make like cheap shit that doesn't use a lot of memory. Like, think about IoT and these kind of things. And like, we had a discussion about this. Like, most of the opposition for 32-bit comes because of x86. Because x86 had a merge model, we could call it, right? So you had like the code that was used for x86. Whoops. x86. You needed to pass through that code to go to the 64-bit part of things. So it made everything shit. But here, we're literally talking about like long arch 64 being a thing. And long arch 32 being a thing. A little bit like ARM. So you shouldn't have to give a fuck about the other. Like, for sure they'll share a bunch of drivers. But who cares? So it's probably good news. Apart from that, it's not that interesting. Well, I don't know if you were there for any of it, Cardian, but we did some PCIe research. So now we have a fucking deep dive into the bleeding edge. You're ulting. Yep, I'm ulting. So yeah, we're having fun. Alright, enough for today. I need to go for real. I need to go. Love you all. No exciting... No exiting news and... You're making myself yawn. That's okay. I'm always the... I'm good at that. You mean exciting? Excitement? Or exiting? I'm fucking confused here, okay? Excitement. Well, it is. This is exciting as fuck, okay? It is. So, the yawn phenomenon. Okay. So yes, this is all fucking exciting, but I need to make the video for it to be exciting. And we just went through a whole explanation about how we're going to do fucking, like, assembly magic in order to test some address, because TLDR, I'll make the fucking explanation for you, Volt. Listen up, bitch, okay? So what we have, okay? We have the address space, okay? That's for your program. So here, boop, 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 we have the address space, how it's divided. Here is the kernel, here is the user space, this is the middle. What happens if the user sends something for the kernel to do that contains a pointer, and that pointer, doop 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 doop, we don't know where it points. It may go to the kernel, it may go to the user space, but we need to make sure that it's safe. And to make sure that it's safe, we need to check if it's above the line. If it's above the line, the most important bit will be 1. If not, if it's a 0, it means that it's safe. Okay, easy enough. So what we can do is we can do a rightward shift with fucking words. Algebraic rightward shift, which means that if this value is a 1, it will produce other 1s. If it's a 0, it will produce other 0s. So by doing that, we can set everything to 1 if it's a bad value, or set everything to 0 if it's a good value. Then we can do another rightward shift which will produce a 0 here, but of course in our good scenario will produce absolutely fuck all different. Then we can invert all of those bits, which in the case of the good value will produce a bunch of 1s, and in the case of the not good value will produce a 1 here and a bunch of 0 there. And after that, what we can do is we can do AND with the original value. So what it would do is, in the case where it's a bad value, it would point us right in the middle of our fucking thing, right? So remember the memory thing? Doop 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 doop. It will point here instead of the kernel. Kernel is safe. Kernel is happy little kernel, right? So if it's a bad value, algebraically, it will make sure that it points to the middle, while if it's a good value, algebraically, or mathematically, or whatever the fuck you call it, it will make sure to print the same fucking value, meaning that it will point directly to the right place. Understood, bitch? Understood, Volt? We used fucking math to know if a pointer is safe. No need ifs, no need speculation barriers, only big dicks. As good as I can, exactly. Vol did not ask me, okay? I just wanted to. I wanted to. Okay, the only thing I understood today was this shit. Volt, I love you. I love you so much. Holy shit. Ah. Okay, I was saying, like, if I don't explain why if is not a good idea, like just a if checking the most, the highest bit, like why this would not work. And you literally said it. You fucking said it. I love you, okay? We've got a fucking mind connection. Anyway, yeah, I explained that. Now, you might be tempted to use an if to test the most important bit, but it would be a mistake. Ifs introduce branching, which is undesirable in critical code. Got you covered! Alright, enough for today. Love you all. Alright, bye-bye. We see each other tomorrow, probably late, but who gives a shit. Bye!